As part of the Further Stats 2 course, we need to conduct a variety of different hypothesis tests. So for this video, we're going to look at a hypothesis test on the difference between two means. So if we had two different independent distributions, let's say x and y, that each had their own value for mu and their own value for sigma, we can actually test a hypothesis of whether or not these two means in the two different distributions are going to be equal to each other. In conducting this hypothesis test, we're going to need to calculate a test statistic, which is displayed for you here. And if we calculate the test statistic, we can draw a conclusion just like we would with any hypothesis test. Okay, this test statistic is in the formula book, and you'll always be able to refer to it in its entirety, but with enough practice, you'll be able to commit this to memory. So in this first example that I'll go through, we're told that the weight of boys and girls in a certain school are known to be normally distributed, with standard deviations 5 and 8. So standard deviation for boys is 5, standard deviation for girls, 8. We have a sample size of 25 for the boys and a mean for the boys of 48. And the girl sample size is 30 and the mean for the girls is 45. So I've collected all of that data together. We are told that they're both normally distributed, so I can actually describe them as a normal distribution. So B follows a normal distribution, 48 and 5 squared. G for girls follows a normal distribution of 45 and 8 squared. Okay, we're going to state our hypotheses. The hypotheses for difference of two means is firstly that the two means equal each other, which I can rewrite as one mean minus the other equals 0. This will be important in a second. Alternate in this case is that the mean for the boys is greater than the mean for the girls. Our hypothesis always has a significance level, and here we're going to make use of that z-score test statistic. So I'm just going to write it out in full. This is exactly what you get in the formula book, and then I'm going to substitute in our appropriate values. In this case, I'll change the variables just to match. And if you notice in the brackets here, I've got mu b minus mu g, the mean for the boys minus the mean for the girls. And I did write with my null hypothesis that this equals 0. So I'm able to substitute 0 in for this bracketed expression. Okay, just go ahead and substitute each of these values, and that will calculate your z-score. And that gives us a z-score of 1.6947. So using our 5%, let's see if we can make a comparison of that z-score. Can we tell how significant it is? Here's a diagram. We're used to seeing this. The z-score that matches up with this 5% is 1.6449. So this can be found by using the inverse function on your calculator, the inverse normal distribution function, or by looking in the formula booklet. There's a set of tables, the normal distribution percentage points. So at this point, let's make a comparison. Our test statistic would be here in the shaded region, in the rejection region, so we have a significant result. Our test statistic is larger than the critical value that we just looked up, so we can conclude that we should reject H0, and then obviously in context, we can say we have sufficient evidence to suggest that the mean weight of the boys is greater than the mean weight of the girls. And that's our hypothesis test completed. Now, just to link this to a technique that you're used to, we could have gone ahead and actually found a probability that Z was greater than 1.6947. If we'd done that, we would have got a probability that was smaller than 5%. And as you recall, we would then have rejected H0. So both of these techniques are available for you to use. The Z-score technique is going to be the one that's actually expected from you. This is what you'll see in mark schemes, and this will follow through in some of the additional hypothesis tests that we'll do in this module. Okay, so let's look at another question with a slight variation. So in reading this, you see that each of the values are actually the same as we had in the previous example, but it's what we're testing. It's the hypothesis right at the end. So we're checking whether or not there's evidence that the mean weight of the boys in the school is more than 2 kilograms greater than the mean weight of the girls. So the whole setup is going to be very similar. It's in our hypothesis that we're going to see the difference here. So I'll speed through this so we can just get straight to those hypotheses. Okay, so the null hypothesis this time is that the mean of the boys is equal to the mean of the girls plus 2. If we were to rearrange this once again, I'll get that the difference between them equals 2. So this is a way to indicate that the boys' mean is expected to be 2 above the girls' mean. Alternate hypothesis is going to be greater than, and our rearrangement once again, the difference is greater than 2. We're going to go ahead and substitute into our test statistic. Remember how I used the fact that the difference equals 0 in the previous question? Well, now I'm going to use the fact that the difference equals 2 and substitute that into the test statistic. So we'll go ahead with our substitution. This bracket is going to equal 2. Everything else is going to work exactly the same way as it did before. We'll get our test statistic. We'll make a comparison with the 1.6449 since we're still doing 5%, and then we'll draw our conclusion from there. So the difference here is in the hypotheses, in the value that goes into the bracket in the test statistic, and we may well see a difference in our conclusion as well. Okay, so here, this test statistic is no longer in the critical region. It's outside of the rejection region. It is not a significant result. We do not have enough evidence to reject H0. So comparing the Z-scores, or if you want to go ahead and work out a probability, we'll draw the same conclusion. And finally, just to write up those conclusions, we have insufficient evidence to reject H0. There is not enough evidence to suggest that the mean weight of the boys is more than 2 kilograms greater than the mean weight of the girls. And the last type of question that I want us to look at before you get started, a couple of things to point out here. We're not told that the distributions are normal to begin with. So we don't know that, but we'll collect their variables anyway and be careful to not assume that the original distribution is a normal distribution. We're going to go ahead and do everything in the same vein because the central limit theorem says if we're working with the mean of a sample from a distribution, the mean will follow a normal distribution. So we are making use of the central limit theorem. Our null hypothesis that they equal each other. The alternate in this case is a two-tailed alternate hypothesis that they are not equal to each other. So we pulled that out of the text of the question. Significance level needs to be divided by 2, and we'll have tails both at the bottom end and at the top end. We can go ahead and calculate the Z statistic in the same way that we have been doing up to now. And then we can make a comparison between the Z scores and the critical region Z scores that we find. So we've got a z-score of negative 0.645, and we just want to see whether or not this will be in the critical region, in the rejection region. So 0.025, the z-scores that match that are 1.96 and negative 1.96. I can demonstrate that it lies outside the critical region. We do not have a significant result, but obviously we need to document this, either compare these z-scores or work out your probabilities. From there, as usual, as expected, we'll make our conclusions. And in this case, we do not have enough evidence to reject H0. There is not enough evidence to suggest that there's a difference between the lifetimes of the two battery brands.